Assalamualaikum and hi, my name is Mohamad Syahmie Izzuddin bin Mohamad SUFFIAN. So my metric number is B0822100047. So today I want to introduce you about introduction of assignment. So the title that we choose is Control System for Automatic Brake Toaster. So what is control system? So the first one is to manage, command, direct and regulate the behavior of the other device of system. Use control loop to achieve desired output, consists of sensor, controller and actuators, and can be open loop no feedback or closed loop, which is with feedback. So the last one is inertial in automation, robotic and industrial processes. So what second order system? A system categorized by the differential equation of the second order. The key parameter is natural frequency and damping ratio. And the third one is response type, which is we have underdamped, overdamped, critical damp, and the last one is underdamped. And common in system like mechanical vibration, electrical circuit, and control system. And why we choose toaster? In toaster, a second order can be applied to model or control heating element temperature, ensuring stable and consistent toasting by managing the heat response and avoiding temperature overshot. So let's jump to the simulation. So this is a closed loop, which is we use a relay control heating toaster, and the feedback is those quality measurement device. This is also the calculation that we use for find open loop. And the last one we assume is the 0 is 2 and the pole is 2s squared plus 4s and plus 20. So by using command and MATLAB, so the first one we put h equal to tf, that tf refers to transfer function. Then we put a transfer function for the numerator is 2 and the denominator is 2 for 20. So that we get, after that we get a transfer function. So after we put the h, so we the next one is we put the step plot, which is step plot in bracket h, and we got the step response. And the last one, if we want to find the rise time, settling time, and the overshot, undershot, peak and peak time, so we put a step info bracket h. So the last one is after we compute all the command, we get the step response. Then this is our step response, which is underdamped. So after all things that we do, so we get the underdamped. So that's all from me. Thank you.
Assalamualaikum. My name is Mohamad from HASROL. My metric number is B0822105002. I will continue for the calculation. First, we need to find the natural frequency. We assume the equation is 2 over 2s power of 2 plus 4s plus 20. So how to find the natural frequency? The formula for natural frequency is omega n power of 2 equal to 20. So after we calculate, we get a 4.4721. Next, we find damping ratio. The formula for finding damping ratio is 2 ratio omega n equal to 4, and after we calculate, we get the 0.4472. The third one, we calculate the peak time. The formula for peak time is pi over omega n square root 1 minus ratio power of 2. We calculate and we get the 0.7854 second. For the settling time, the formula we use is 4 over ratio omega n. we calculate and we get a 2 second. Last, we calculate is percent overshoot. The formula of percentage overshoot is E in a column minus ratio pi over square root 1 minus ratio power of 2 times 100, and we calculate, we get 20.78%. This is a comparing value between simulation value and calculation value. Calculation value peak time for the simulation value is 1.0592 second, and for the calculation value is we get 0.784 second. For settling time, the simulation value we get is 3.5359, and for the calculation value we get a 2 second. For the percent overshoot, for the simulation we get 35.067%, and the calculation value we get 20.78%. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is FARHANNIZAM bin HAMDAN. My meeting number B0822100479. Today I will explain about steady state representation and stability of the system. First, steady space representation. For the transfer function, we use 2 divide 2s power of 2 plus 4s plus 20. Then we get for R, we use metric formula and we get output system. For the explanation, state space representation goes beyond just input and output like a transfer function. It uses differential equation to describe a system internal state variable and how they change with the input. This helps predict the final output and understand the entire process, making it valuable for analyze and control complex system. Second, stability of the system. For the calculation, we still use the transfer function, same transfer function. This table shows how to determine a system stability using the Rowe-Howard criterion. According to the Rowe-Howard theorems, the number of root of the polynomial in the right half plane is equal to the number of sign change in the first column. Since there were no sign change in the first column, the system was stable throughout the calculation. Therefore, the system is stable.
Assalamualaikum. My name is ROSLI. My record number is B0822100135. Today I want to explain about the steady state error calculation. Step input is formula is C step infinity equal to lim over S. S is 0 multiply 1 over S multiply 1 plus GS. Okay, insert the value is system infinity equal to 1 over 1 plus lim S equal to 0 bracket 1 divided by 2S plus 2 plus 4S plus 20. The value is 0.091 second. Calculation for RAM input. The formula for RAM input is RAM infinity equal to lim S equal to 0 multiply 1 over S plus 2 multiply by 1 plus GS. So the value is lim 1 over 1 plus S plus bracket 2S divided by 2S plus 2 plus 4S plus 20. The value is infinity. So the parabolic input calculation is E parabolic infinity lim s equal to 0 divided by 1 per s possible bracket 1 plus gs. So insert the value is lim s equal to 0 1 over s possible plus 2s possible divided by 2s possible plus 4s plus 20. The value of E parabolic infinity is negative infinity. So about the expression is the steady state response of a system reference is to its behavior at the time approaching infinity. So the transfer function describes about the relationship between input and output of a linear time invariant system or in the frequency domain. We can find the steady state response of system distribution by a transfer function by analyzing its behavior, the frequency, the input signal approaching 0. Okay, it is because the steady state response to a constant input. For the transfer picture, as a approaches 0, the constant term equal to 20 is the denominator dominates, and the transfer function approaches a constant value of 2 over 20, which is 0.1. This means that is the steady state, the system will gain a factor of 0.1. In other words, a constant input, the output will be 0.1 times the magnitude of the input. Okay, next. For the discussion is we know about the automation toaster is a closed loop system. A closed loop system is a type of control system which is controlling action of dependency of generation output of the system. In a simple word, this system, the output of the system control input applied to the system. For automation toaster, the load output is color of the bread. If the color does not match the net color, the toaster will be the bread until it get the net output. From the MATLAB simulation, the graph show that is the undamped second order system. We can get the value of peak time, settling time, PS, and percentage overshoot, percentage OS, to be compared with calculation value. From the steady state error, we got 0.091 value for step input. The ramp and parabolic input were infinity. This is because the error system depends on two factors, which are the type of system and input. So the conclusion is we can conclude the automation toaster is just a heating device in its closed loop system with underdamped second order dynamic. Unlike a simple on-off switch, the toaster is a feedback loop. You set the desired darkness, the heating element responds open loop, and the sensor monitor a bright color is output. The feedback is compare your preference and adjust the heating if you need. This closed loop design, the underdamped dynamic, ensure constant result. A delightful example of engineering working behind the scenes of the everyday conversation. That's all from me. Thank you.